Would you like to understand how buildings can be cooled down without using any electricity or fuel? Then this video is for you. Because today I'm going to show you guys how for the past 15 years we've been building buildings that are able to cool themselves completely naturally without using any electrical or mechanical component. It's all based on basic physics. Before we start, for those who don't know who I am, my name is Moin Nodehi and I'm the founder of Biotonomy, which is one of the leading organizations in the world who design and builds green building. And we've been doing this around the world, from America, Europe, South America, Asia, in different parts of the world. We've been building these buildings and we've been cooling them naturally by using the 4 strategies that I'm going to show you today. So let's dive into it. The first thing that we need to do in our design is to design the building in a way that air can move, right? So in conventional building, what we do is that we use fans. We use fans and ventilation to push the movement of air towards where we want it. But there's actually a natural way of moving air. So point number 1 that I have here that I'm going to show you is called moving the air, right? So this is the first thing. How do we move the air without depending on using electricity and fuel? The second thing that we need to design is how do we cool that air that we're about to move. So in conventional building, that air is cooled by using fuel or some sort of electricity. So when the air enters the building, it is cool. So I'm going to show you guys how you can do that completely naturally without using any electricity or fuel. Then we also going to talk about how do we design the building to actually block the sun during summer, because it's not only about cooling the air, it's also about minimizing the solar intake during the hot seasons. So how do we design the building to do that? And the 4th strategy is how do we store those temperatures, those cool temperatures that the building now is producing. How do we store that? If we don't store it, then we are constantly going to need to produce it. So I'm going to show you a combination of using these 4 strategies in a building so you can completely cool it naturally. So let's dive into it. Let me remove this so I can show you in a design. Okay. So building that, for example, has this shape. We do a simple 1-story building, and these strategies that I'm going to show you can be used in urban high-rise building in different shapes, but I'm just going to show you the concepts, right? So normally you would have windows in a building, and if you have experience in a room or in a house that if you would open a window, for example, let's say this is a window that opens like this, and then you just happen to have a window here as well on the other side. So I'll just do it like this. If you've had this experience, that if you, in a building or in a room, open the window on either side of the building, what happens? You get air flowing through your building. So it kind of feels like a breeze, right? Now, that is, in simple terms, called a natural convection. It's actually physics, right? Because if you only open one, then you don't get the air to pass your building. So you don't feel the breeze like that. So in order to make the air move, we need to have this in mind when we're designing our buildings. How do we create an opening on one side, and how do we create an opening on the other side, so when we open these two openings, we have the air to be able to pass through our buildings. Can you imagine that 99% of architecture just fail on this basic concept of having air flowing to the building so we make the building breathable? So that's number one, how to make the air move. Very basic, very simple. This you need to have in mind when you do your floor planning, so you really think of, where do I put the openings? You cannot just put openings because of the beautiful views, of course, and the natural light, but you also need to have in mind, how do we create air movement throughout the building? Now, let's look into how do we cool this air, because in summer, this heat and this wind, when it enters, it's actually not going to enter with comfortable temperatures. This will enter with a hot temperature. So in fact, it will overheat your building, and you don't want that. You want your building to stay cool. So there is a way to cool the air, and it's called earth tubes. So if you've never heard about this concept, it's a way of using the cool temperatures underneath the earth to cool the air. So instead of the air having to come from a window, what we can do is that we can go and place what we call cooling tunnels underneath the ground, and you only need to go about 3 to 4 meters underneath the ground. So what happens is that when the hot air in summer passes by here, now, before I explain how to cool it, remember, we still have this opening, not this one, but we still have this opening here. So now, when you open this window, air is going to be pulled from here, going through the building, right? So we already achieved number one, because we have one opening here, and we have another opening there. So we have a natural convection happening. Now, because we are 3-4 meters underneath the ground, the temperatures around the tube here is actually cool. So we have cool temperatures around the tube because the sun is not able to penetrate that deep. So naturally, when you dig down, the temperatures are cooled 3-4 meters. The only thing the sun can heat really is the top part of the soil, which stays warm because the sun hits it, but the rest is actually cool, right? So what happens is that as soon as this hot air reaches the lower point, it actually starts releasing its temperature. Why? Because based on the laws of physics, heat always moves towards cold. So the temperatures that enter here in the cold area now, they actually become cool because they start releasing their temperatures towards the cool area. And then eventually when it comes into the building, ta-da, it's cool. It can comes in 19 degree, 20 degree, 22, 3 degree maximum based on our experience. So now you've basically learned how to move the air by, in your design, creating two openings on either side, and how to cool that hot air during summer. Okay? So just by doing this, you've created a natural air conditioning system, because normally this whole part of moving the air and cooling the air requires electricity and mechanical components like fans, and they have a lifespan. They can, have a 10 to 20 year lifespan depending on what products you're using, and then eventually, they need to be maintained, they need to be repaired. But this is actually an ancient way of cooling buildings, and these systems have been installed almost 1,000 years ago, and they still exist today. There's literally cities in the world where you can go and you can see these systems installed in a very large scale and still working after so many years. So this is nothing new. It's just lost knowledge that architects have completely forgot, because most architects and engineers went to university, and in the university they taught them how to use air conditioning, how to use fans. They never taught how to use physics to cool the air, right? So now you know that, and now you're already ahead of most designers out there. Now, the third thing that we want to also have in mind to really make sure that this thing is working is that during summer, we need to make sure that we don't bring too much sun inside of our building, because from one side, we are trying to cool it with the air, and from the other side, we need to make sure the sun is not disrupting this process. So the sun in summertime has normally a higher angle, meaning it's normally, somewhere here, while in winter the sun is lower depending where you are in the world, but it's normally coming into the building like in this direction. If this side of the building would be facing the sun, which in the northern hemisphere is south, and in the southern hemisphere is facing north. So if we are facing the sun here, then the sun will be getting into our building like this. Now there is a conflict here, because from one point you have created cool air to come inside of the building, and then from another side you have the sun heating up that air. So now your cooling system doesn't work, right? So what you need to do is you need to design your building in a way, and this is very simple to do today with today's technology, with today's 3D modeling softwares. This is very easy to do. You have to design your building to make sure that the sun cannot enter during the hot seasons. So all you have to do to achieve that is to figure out, for example, your roof here. How far do you need to extend your roof to block that sun? And you see, if we extend it like I did there, well, now the sun is not able to enter. So it will basically just hit your roof and everything beneath it will stay in shade. Like, that's a huge improvement in terms of thermal comfort, because the sun brings a lot of degrees inside. So just by being able to design the building correctly, we make sure that we don't overheat it with the sun. So now we've achieved to keep our building in shade during summer. We've achieved to take the hot air from outside, cool it, and bring it down. So now we should be good, right? Now we have cool temperatures in there. Not really. There's one more thing missing, which is storing that temperature. Because eventually, during night, you also want to make sure, maybe you want to close your windows, you still want to make sure that your building continues to stay cool throughout the entire day and night. So what you need to do is to integrate a storage, a way to store this temperature. And the way people have done this for many years, for thousands of years, is by using a concept that is called thermal mass. Thermal mass is basically nature's way of storing temperatures. You can store both warm temperatures and you can store cool temperatures. And the way you can think about it is, have you ever touched a stone and you felt that it was super warm? Or have you ever touched a stone and you felt it's super cool? Well, that's nature's way of storing temperature. It happens in nature every day, all the time. Temperatures are stored. Now, if we understand this concept and integrate it into the blueprint of the building, then our buildings can actually store temperatures. We can literally take temperatures from one season and use it for another season. We can take it for during the day and using it during the night, right? So the way to do this is to use materials that has a high density. Materials that have a high density means that they don't have pockets of air inside of them, or they have less pockets of air. So certain materials that are heavier, are more compact, are better at storing temperatures. For example, if you take a piece of stone versus a piece of wood, the stone is going to be heavier because it has more dense mass, meaning it has less air inside of it versus the wood. So the stone will be able to store temperatures. Same thing with concrete. Concrete is basically humans' artificial way of creating stone type material, strong, solid material. And concrete as well is a material that has high density. Soil has also high density, especially if you compact it. There are walls that are built out of something called rammed earth, which is using earth in a structural way, and that has a high density. So there's a lot of alternatives for materials that you can use that can store temperatures, right? So in your design, you would need to place those kind of materials strategically. So, for example, in this building that we've been designing, if we would place thick walls here in the back, these can be stone walls, it could be a concrete retaining wall, it can be actually a rammed earth wall, you know, something with a lot of mass. And then as well, if we also make sure that our floor as well has a lot of mass, this can be a concrete floor, this can be an earth floor, but not a wood floor, right? Because wood doesn't store temperature. Same thing here. We don't want this to be wood because wood cannot store temperature. You can use wood here, but here where you want to store the temperatures in the back, you should not, right? So what happens is that all those cool temperatures that is now created here gets stored inside of these materials. So this wall will basically stay cool. And so will this mass, because there is no sun that is heating this up. It is staying inside of summer. It is actually staying in shade. So when it stays in shade, it stays cool. So what happens is that it will also basically, it will absorb all these temperatures that are these cool temperatures in the room. It will be stored there, and then it will also radiate into the building. So now your wall, your floor is radiating cool temperatures, and the air coming inside of your building is also radiating cool temperatures. So there you go. That's all you have to do. You just need to combine these 4 strategies together in your blueprint to get the building to stay cool. So first thing is move the air. Second thing is cool the air. Third thing is block the sun. And the fourth thing is to store the cool temperatures. Now, we have done this in so many buildings around the world, and every time people walk into these buildings after they're built, we blow their mind, because people cannot believe that a building can be cooled like this naturally. We are trained as designers and engineers and architects and whatnot, and even people, we grew up in buildings that are constantly being cooled, which with air conditioning system, we've forgot that physics, if we use physics, we can actually cool our buildings. And so this, as I mentioned before, it can be implemented on a large scale. You can use these in residential blocks, office blocks, in urban areas, in supermarket, in hospital. There's no limit. It's just that we need to change our mind state of how we design these buildings, because if we don't take into account physics when we're designing the buildings, of course they're not going to work with nature. They're going to depend on mechanical solutions. And then actually the evil cycle that we have with using mechanical solutions for cooling our buildings is that air conditionings, what they really do is they take the hot air from inside and then they throw it outside. So actually we're not cooling anything. We're just moving the hot air from one side to another side. And then what happens is that, imagine now hundreds and millions of buildings doing this. We are basically overheating our cities because we take the hot air from inside, throw it outside. Now our streets are uncomfortable. And actually, in Europe today, there is more people dying from overheating than car accidents. Can you imagine that? Like, that's how bad our buildings are designed. People are literally dying because they're overheating. And in fact, I've worked in many countries around the world, and I can tell you, the majority of the people still don't have access to air conditioning. If you live in a country where you every day are using air conditioning, don't think that this is something that every person around the world have access to. So actually, most people are just living in shitty boxes that are overheating constantly. And so for our cities that are over-consuming energy, we should, instead of using fuel and electricity to cool them, we should use physics, because physics doesn't consume energy. Physics doesn't require maintenance. Physics does not break. Like, once you get your building to work with physics, it will always work. You cannot even argue with physics, because it's just a law of nature. It just is there every day. It shows up and it works. So if you really want to master green buildings, you need to understand that there is so much more than just making these buildings green. There's all these physics and biology that you need to learn to integrate into the building. And if you really want to know how to design buildings like this, if you really want to understand the details behind it, what kind of materials should you use for the cooling tunnel, what kind of dimension should you use, you know, and what do you do in different terrains, how do you integrate the cooling system, how does the storing look like, all of these details is what we teach you inside of the academy. So if you really want to make an impact in this world as a designer, as a builder, as a policymaker, if you're working with construction, with cities, then you just have to learn this, because this will help us to really change our cities, improve our buildings, and create environments that actually are working in a healthy way. So we are about to open the academy. If you've been interested, if you want to master this, then I really recommend that you jump on this program, because I look forward to see you there. Thank you so much.